Hey, it's Mr. Barr, and today I am dressed like this. Why am I dressed like this? You can't see me yet. Boom! Today was Be a Character Day or something like that at school. So I am dressed like, you can pick a lot of different people. I'm actually dressed like Grandpa in the Waltons. I think that's Zeb Walton in the Waltons. There you go. What did you dress like today? Okay, so here we go. We're gonna do rate of change. Get my notebook ready to go. Rate of change. So our goal is I can use functions to model real life situations. Why? Functions are just fancy equations that do work for us and help us understand the world around us. I want to understand and create functions. So what does linear mean? Well, linear means a straight line. What is y equals mx plus b, y equals mx plus b? That's the slope-intercept equation. And what does the m represent? Well, the m represents the slope. So good job if you know the answers to these questions. Today we're just going to expand upon the idea of slope, an idea that hopefully you're already comfortable with. Here we go. So in your notebook, let's get down the word rate of change. Okay, so our notes are going to start with our name. And our title is rate of change, also known as slope. So rate of change and slope are the same thing. So we know that slope is called rate of change, which is rise over run, which is change in y over change in x. So we're going to get all of that into our notes. So slope equals rate of change which equals rise over run which equals change in y over change in x. Which actually makes sense because y is the rising axis and x is the running axis. So when I look at this graph, I already know how to find the slope of this graph. So we're going to do that in our notes. How do I find the slope of a graph? I find two good points. I draw the slope triangle. I find the rise and run. But we'll put this into our notes. It's not going to be perfect, but we'll make it as perfect as we can. So this is our y, this is our x. Let's see if I can focus this a little bit better. There we go, a little bit better focus. Here's my line. So to find the slope of this, I start by finding two good points. I draw in my triangle. Find two good points, draw a slope triangle. Count your rise and run. So in this case, I'm going to go with, I don't know, I'm estimating here, but 1, 2, 3, 4. Let's call this 5 over 2. Put rise over run. And add a negative if needed. So in this case, our slope is 5 over 2. This is not new material. We have done this before. Find two good points. Draw the slope triangle. Count the rise and run, put rise over run, add a negative to negative lines. That's how I find the slope of a line. Now for this one, I'll do this actual problem. See how close I was. So I know we just kind of estimated it in the notes. So I find two good points. Good point, good point. I draw on my slope triangle. I count my rise, I count my run, I put the rise over the run. I simplify it down to just a 2. The slope of this line is 2. There we go. Rate of change, or the slope, is 2. But now, it's a table. I want to find the slope of this function. But instead of giving you a graph, I've given you a table. How can I find the slope from this table? Well, these are just a bunch of points, aren't they? Isn't this 1, 0, 2, 1, 3, 2, 4, 5, or 4, 3? One thing I could do is I could graph these points. We could graph it. We could absolutely graph this. But I have a better solution, and that's what I'm about to teach you. You could graph this and find the slope, but I'm going to show you a better way. But I don't want to graph it. No! I'm a crying little baby. I do not want to graph it. Okay, so how can we do it? Here we go. I'm going to show you how to find the slope from a table without graphing it. Remember, when I say slope, you say rate of change. When I say rate of change, you say slope. They're the same thing. So I have this table. I have x, y. And on this table, I have 1, 2, 3, 4, and I have 0, 1, 2, 3. And I could graph this, but I don't want to graph it. So what I'm going to do is I'm going to find the change in y, and the y is the rise, and the change in the x, which is the run, because x is the running axis and y is the rising axis. It does not matter which points you use. I could use these two or those two or those two, but what I'm going to do is I'm going to take any two and I'm going to find the change. Ready? So how did x change? It was at 2 and now it's at 3. It went up by 1. That's your run. How did y change? That's your rise. What I'm doing is I'm finding the change in x and the change in y. Change in x, that's your run. That's your rise. Oops, you can't see what I'm writing. Find the change in x, find change in x, that's your run, and change in y, that's your rise, and then put rise over run. Which in this case is 1 over 1, which equals 1. And that's how I do it. Over and over again. So let's do another one. I like these problems. So this one, so I find my change in x. Well, it was at 1, and now it's at 2, which means it went up by 1, plus 1. Y, it was at 96, now it's at 97, it went up by 1. This is my rise. This is my run. I put rise over run, which is 1. Find the slope of the line that passes through 6, 4 and 4, 9. I could graph it, but instead of graphing it, I'm just going to put it into my table. 6, 4, 4, 9. Find the change in x. Well, it was at 6, and now it's at 4, so the change in x is negative 2. Find the change in y. It was at 4, and now it's at 9. That's a plus 5. So this is 5 over negative 2. Now, I know some of you want to put the negative here. I put it up here. It's all the same stuff. You can have the negative on the top, on the side, or on the bottom, but it's better on the side or on top. So negative 5 over 2. Negative 5 over 2, or negative 2.5. And I just left the negative on the bottom where I just told you don't leave it. Let's do another one. Let's draw it as a table. So let's go 3, negative 2, 1, 6. The change in x is negative 2. The change in y is positive 8, right? Negative 2 up to 6 is positive 8. Rise over run, which is negative 4 when I simplify it down. So here's our bottom line. Turn the points into a table if necessary. Find the change in x. Find the change in y. Let's put that one into our notes. We'll do one more. Let me get my lights to turn back on. Let's go with 3, 7 and negative 1, 10. So let's find the slope between those 2 points. So I'm going to make my table, x, y, 3, 7, negative 1, 10. We'll find my change in x, which is negative 4. It was at 3, and now it's at negative 1, so my change in x is negative 4. My change in y, it was at 7, now it's at 10, is 3. So my answer is and yes, I put the negative on the 3 instead of the 4. I just moved it up there. It's the same answer either way. All right, hey, thanks for watching and have a good day.